Hello, Maurieo! In this video, I'm going to take a look at a skydive. A skydiver drops from a hovering helicopter and falls freely for 5 seconds before opening her parachute. What speed has she attained when the parachute is opened? Well, over here on the right, I have put up the big 5 equations for motion, and they're all directed there. Now, each one of those equations has some of the variables, but not all of the variables. So it's a matter of, in each case, working out what information you have, and then finding which one of the big 5 is the appropriate formula to use. I've listed here briefly what the variables are: velocity, final velocity, initial velocity, time, acceleration, and displacement. Remembering, of course, that displacement is the distance between the start and the finish, and is not necessarily equal to the total distance taken to get from the start to the finish. It's the actual resultant vector. So in the first one, we will need to work out the speed, and we know the acceleration, we know the time, we know the initial velocity because that's 0, so quite clearly equation 1 is the one to use there. Equation 1 in this list, the equations can be listed in any order. I've just chosen the particular order I've got there. So let's fill in what we've got. We have VI, the initial velocity of 0, and then the acceleration 10, which we're taking the acceleration due to gravity as 10 just for ease of calculation. We do know that it's closer to 9.81. Times 5, which is t, the 5 seconds. Now, just putting the units there, the acceleration is meters per second squared, and the time is 5, so we can straight away see that one of the second at the top cancels out one of the seconds on the bottom, and we're going to end up with meters per second, which we're showing as meters per second to the -1. Now that's pretty good, because we know this is a velocity that we're looking at, or speed, velocity. There is a slight difference, we know that, but that's the final velocity, and it's 5 times 10, of course. 0 plus 5 times 10 is 50 meters per second. So there you go. On to the next one, number 2. How far did she travel in her fall? So we're looking for D, the displacement, and we've got a couple of equations there that we could look at, but let's just take the number 2 there. D, VI we know, T we know, VI is 0, so that cancels out, equals a half. The acceleration we know, and T squared we know. So I'm pretty sure it's equation 2 that we can use there, and that 0, VI 0 times T cancels out, plus a half times 10 times 5 squared. So just rewriting that as a half times 10 times 5 squared. Time to look at the units. So the acceleration given by the 10 is meters per second squared, and the 5 seconds for the time is seconds squared. So we get seconds squared cancelled out from top and bottom, and we're just left with meters. That's a displacement that's measured in meters, so all good there. So let's do the math. A half times 10 is 5 times 25, 125 meters is the length of the free fall. So she fell for 125 meters. And then finally, what was her average speed while falling freely? Average speed, you could possibly use one of the big 5 there, but we all know that the average speed is the total distance traveled over the total time taken, and we have this information here. So we're just going quite quickly to the VAV, the average velocity, 125 over 5. let's look at our units, meters per second. That's what we're looking for in a velocity, so 25 meters per second. So there you go, Maurieo analyzes a skydive.